Hello and welcome back to another video in the Learning to Program series. In today's video, we're going to be covering the basics of functions. In programming, functions are sets of repeatable code that provide flexibility and help us create more maintainable code because we can place a meaningful name to the set of operations that are performed within the function. We have plenty of experience of using functions in this series so far, namely using the slices.equal function or also just something like the append function. But in this video, we'll be uncovering how to create a function, all the features of functions, and how we can help modularize our code. Let's first go over what makes up a function. We've already been using the main function, which is required in the main package of a Go program, but let's create another function that can be called from main or several other types of functions. The first property that a function definition will have is the func keyword, declaring this is about to be a function, anything after this will define it. Then we have the name of the function, so let's name this, say, hi. Then we have the argument list, basically all the inputs that we can give to the function that will modify its behavior in some way. In the main function, we see that we take in no arguments with these parentheses. There's nothing to pass in, we just simply run the program. But in this function, I wanted to say hi to somebody in particular. So we can open up the parentheses, and in here we can specify the argument list. So I can say I'm going to pass in a name here, and it's going to be of type string. After this, we can specify the return type, so it can be string and whatever you want it to be if the function needs to produce something. But if the function doesn't need to return any particular value to us, then we can just omit it and open up the braces. And then within these curly braces, we write all the code that it needs to run and produce some value or print something out to the screen. So that's like the high level view of functions, but now let's go into each piece individually. Let's begin by covering naming conventions and just general function naming in Go. To demonstrate this, let's start off by creating another file and another package. So we have our functions folder here. We'll create a subfolder called extras, and then within extras we will create a new file called extras.go. Now the naming convention here is kind of all over the place. This part does not matter when it comes to the functions. But to create this new Go file, we'll start with package, and then it's in the extras folder. And in here, I want to define a function that I can go use over in my main.go. And let's just have it be printing the name of somebody. So I can have a func called say hi, and we'll give it a name that's a string, and then we can print out the name after saying hi. So print f, pass in the %s, and then actually before the %s, we have to say, hello or hi, and then put in the new line, pass in the name. We can save, and we can go ahead and import fmt, and we're good to go. So this function will go ahead and print hi, given some sort of name, but notice with the name of this, it's describing what the function is going to do, and it starts with capital S. So if you come from Java, usually starts with their methods and functions with lowercase, so it's a lower camel case. But over in Go, there's no access modifiers like Java has with public and private, protected, so on and so forth. Instead, Go uses implicit access modifiers by having an uppercase or lowercase first letter in the function name. So if it's uppercase, that means it's public, it's accessible from other packages. And so in here, I can call the extras package and then call its function that's within it called say hi. So I'll pass in Colton, save, let's jump down to the terminal and run Go, or let's go up a level, and then we can call Go run period, and we get hi Colton. Now if I change the say hi to lower camel case, so if you're from Java or C or something, we change it to a lowercase s, we already kind of get some warning. It's unused because we can't go use it over in main because it's now hidden from our access. We cannot access that function over in the extras.go file. That's about it for naming functions in Go. Now let's discuss arguments to functions. It's also interchangeable with parameters. I think there is some nuance in the programming world between parameters and arguments, but for the sake of this video, when I say either of those words, it's just referring to this argument/parameter list up in the function header or signature. As we've been working with the func main, we can have no arguments to a function, or we can have one or more arguments/parameters to a function. how it goes is you name the parameter and then you give its data type. And then we can go ahead and add another one. So we can add age and then int after this, and we can continue to adding more and more parameters in this list. But the best functions and most readable and maintainable functions have a very short parameter list. So maybe 1 or 2 parameters, and that's it. If you think you need more parameters, then you might need to split up the function into multiple parts or reevaluate the architecture of what you're trying to create here. So for now, we'll just go ahead and keep it as name string, but let's say that you have multiple parameters or arguments of the same data type. So here I can have name, and then I can do a comma, address, and then keep string after that. So string will apply to both address and name. Idiomatically, I'm not sure what to choose in this situation. Coming from my Java, C# background and everything, I like to have the data type after each parameter name, but that's just my preference. Another thing to note when passing arguments into a function is that go is call by value or pass by value. And what that means is when I pass in a particular argument into a function, its scope only exists within that function. The original value that was passed into the function cannot be modified from within that function. So let's demonstrate this. Let's remove this address and return the function back to what it was. So again, the say hi function is taking in a name and printing it out. So if we actually want to demonstrate what I just said, let's create a name variable in here and we'll set it equal to Colton. And then when we go to pass, we call this say hi function, we'll just pass in the name. So it still has the same exact functionality that I was demonstrating before. But in here, let's modify the name and we'll say name is actually going to be equal to lowercase and then Colton with 3 L's. And then back here, let's go ahead and print out what name still is. So we'll say name equals %s/n, pass in the name. And then we save and it'll auto import format for us. Let's see what happens. So we do a go run and we get hi and then Colton with 3 L's. So this executed because we changed name to Colton with 3 L's. And then back in our main.go, when we come back, we print out what the name value was here. So what we originally had passed into the function, and we get that it's still equal to Colton, what the original value was. So this is what call by value means. It means that we make a copy of the argument. So a copy of name is made, it gets given to the function can independently modify it without affecting other references, and you don't have to worry about other functions modifying other parts of your program when you weren't expecting it. Next, let's discuss about variadic arguments. If you remember in a previous video, we had some sort of slice. So let's create a slice here called s. So s is equal to an int slice, and it holds 1, 2, 3. If I want to append to the slice, we just say s is equal to append given s, and then this is the variadic argument. You can see up here in this documentation that it's ... some sort of type, meaning that we can pass in 0 or more elements to append to this function. So I can call 1, 2, 3, and so on, and so it appends 1, 2, 3 to the end of the function. If we have another slice, let's say like s2 is equal to another int, and we have 2, 3, 4, instead of passing in each element individually at the end, we can just say s2 ... and it will list the elements out individually. So how do we write a function that has variadic arguments? Let's go back in here and let's modify this function that is say hi to actually accept variadic parameter. So what if I want to say hi to multiple people at once? Well, all we have to do is just say name and then do a ... then the data type, and we're good to go. But this doesn't exactly look good because name signifies that there's only a single name being passed in, but this variadic type is suggesting that there are going to be multiple names passed in. So let's change this to names, and then we can just save this. Now this isn't going to be a very pretty print or anything, but it's just to quickly demonstrate what's going to happen here. So let's remove all this slice work right here. And what you notice is that we can still just say hi to a single name. Let's go ahead and save this, and we'll see that it says hi Colton, and we still printed it out. I forgot to remove that. So we can save that and we get hi, and then it gives us that slice notation of Colton. We can also pass in another string. So let's just say Colton with 3 L's. We can save, and this will still run by doing hi Colton and then Colton. Now you can modify this by adding a for loop over into the say hi function, make it look a little bit more pretty, but this was just a quick demonstration that you can have variadic arguments. And one last thing with the variadic arguments is that we can just remove all of this right here, and now when we go to say hi, it's going to say hi to nobody. No value gets put in there, and so the slice is empty. Let's go ahead and take this parameter and pass it back in. So Colton will get passed into the say hi function, but let's also print out what names actually is. So if I do another printf, we can use the %T, so capital T, and we'll get the type of names. So pass in names, let's save. Let's go back and run this, and we get the hi, and then what's actually passed in is that it is a string slice. So just be aware, it's not some weird pseudo type that we haven't talked about yet. It's just a slice of strings that gets passed into this function. Now you may be wondering, what's the point of having variadic arguments? Why can't I just put in a slice of strings here? Well, let's take a look at that. If I say names is a slice string right here, we can save this, but now I can no longer just put a name here. I have to make name into a slice, or make a slice, append name to it, and then pass in the slice to the say hi function. That also means that I can't just make this an empty function or an empty argument either. So if you need a specific use case where you need to pass 0 or more of a particular same data type into a function, use variadic arguments. Lastly, if you're going to use variadic arguments, it must be the last argument in the function. It cannot be the first thing. It cannot be somewhere in the middle. It must come last. So if I have age int, then this still works. But all of a sudden, if I put age at the end, so age int, we get a compiler error because variadic arguments should go at the end. Let's talk about return types now. As we can see with this function, there is no return type, meaning that this function produces no value to give to its caller. So it's void because it's marked as that there's nothing there after the argument list. But let's say that instead of printing this hi ring, we instead return it to the caller. If we want to do that, we know that we want to return a string. So we just give the data type after the parameter / argument list. And now we're going to get some compiler error. If we hover over this, it's saying that we're missing a return statement. We have to return some sort of variable, literal, result of another function back to the caller. So what we can do here is we can say return, and we can use the format package that we have, or FMT, and call sprintf. And here we can copy exactly what we have in our printf statement, pass it in there, and we're good to go. So now when I come back over here into my main function, we need to use say hi in a different way. Let's create a message variable and set it equal to the extras.sayhi. And we still need to give the argument over to say hi, so we'll put in colon. And now we can print out message because we have been given a message from the say hi function, or to be more blunt, just we've been given a string from say hi. So now I do a format.println and I can print out message. So I save this. Let's go ahead and run this, and we get hi colon. We can obviously return any sort of data type that we want. We can change this to an int, but that just means that we have to return some sort of integer down here, so on and so forth with all the other data types. Now, obviously this is a very simple function, and more commonly your functions are going to be way more complex. So let's add in an if statement to this. So if name is equal to colon with 3 L's, let's go with that, we're just going to return a blank string. And let's say that that's all we wanted the function to do. Well, that's incorrect, because all code paths must return some sort of value if you have a data type up here that you're going to return. So if this name is equal to colon, like my regular name, this if statement is going to fail, and then it doesn't return anything. There's no return statement to say, oh, return this type of message or return this string back to the caller. And so therefore we get a compiler error, and hover over here, it says that it's missing a return statement. But this function will successfully always execute if name is equal to colon, that's a lowercase, and 3 L's. So to avoid this compiler error, we must always have a return statement in every possible path that can be taken within a function. So let's uncomment this out, and we see that the compiler error goes away. And so let's save this, and if we pass in colon with 3 L's and run this, we'll get a blank string printed out because that's what we specified over in the function. And as you can see here, you don't have to return a literal every single time back to the user. You can also return functions that return some sort of value back to the caller. So here sprintf returns back to us some string. So eventually this whole entire line right here gets replaced with some string, and then it returns it back to the caller, which is over here in main. One thing that trips up most new programmers is when you go to return a boolean from a function. So let's write a new function over in extras.go, and we'll call it isEven, and it's going to accept a number. So we'll say num is an int, and we'll return a bool. And so in the body of this, we'll take in some result. So let's create an isEven variable, which I don't like this naming convention right here because it's the same as the function, but we'll say isEven is equal to num %2 == 0. And what that means is that if we divide num by 2 and the remainder is 0, then it must be even, right? So then we can just go down here and return is even. That's simple enough. We're returning a Boolean value, right? And then we give that variable down in the return statement. But what novice programmers might do by accident is that they'll say is even equals true. Now what this is it's a redundant statement. This is even variable is already getting replaced with the value of true or false. So this is just the same as saying true equals true or false equals true, which makes really no sense. It's kind of almost more difficult to read that. So instead of doing is even equals true, you can just leave this as is. And if you want to further reduce the lines in this function, we can instead just return this, because I mean this part right here eventually gets put into is even and then is therefore put here. So if we just yank that right there, delete the rest of the function, all we have to do is say return this result, because this operation returns to us some sort of Boolean that we then just pass on back to the caller. We can return multiple values from a function and go. Let's make this a more simple statement here again. So we just return hi %s given a name, but let's say that we want to return 2 different strings. So this will be given a name still, but this name is going to be expected to return a first name and a last name. So let's change what this function actually reads to be. So we'll say get names, and then given a name, it'll split it up and return the first name and the last name back to the user. So if we want to do that, we will have to create what's called a tuple, or what other people say is tuple. So how you do that is you encapsulate the return type at the end with parentheses, and then you just add all the data types that will be returned, and the order does matter. So we get an error here, obviously, because we are just returning a single string, and to be honest, this string is not what we're wanting to return anyway. So now that this expects 2 different strings to be returned, let's find out how we're going to return the first name and the last name. There is the strings package over in Go that we can use, and it has a split function. So if I start typing in strings and then do dot, there's the split function. And what the split function is, let's hover over to get the documentation. It takes in a string called s, and then takes in another argument called the separator, or sep, and that will determine how it's going to separate the strings within the string. And then it returns to us a slice of strings. So let's pass in the name, and assuming that the user or the caller is going to give us a name that is space separated, we will make the separator a space. This produces some sort of value, so we have to store it within a slice. So we'll say names is equal to strings.split, and you might think at first, okay, now I can just return names, but that's not how it works, because names is a slice of strings, but we need to return 2 different strings. So what we can do here is that if we always know that the caller is going to give us space separated names and it's only going to be 2, we can just say names at 0 and then comma separate this, and then names at 1. So I can save this. Let's go back and change this. Let's make a new variable here called names, or really name, and it's equal to $g. And so when I go to call the extras function, I just say extras.getNames. I pass in the name that I have here, which then will return to us a tuple or tuple. Well, how do we accept a tuple back from a function returning such to us? You just create a comma separated list of variables. So all we have to do is say first name, last name are equal to extras.getNames. So now I can have a format.printf statement with %s, then a new line character, and then pass in first name and last name, and we're all good to go. So let's run this to make sure it still works. So we passed in $g to this, it got split up, and then it prints out Colton and G. We can make this even longer, we can add to it, but what's going to happen here is that we're not going to get that extra text here at the end, because we're only returning the first element and the second element of the slice. Now you may be wondering, can I also just name these the values within the tuple? And you sure can. So I can make this first name, because this is supposed to represent the first name, and I think that this makes it a little bit more readable too about what the return values are supposed to represent. So it's saying I'm going to return a first name and a last name to somebody, but as you can see, we're not actually explicitly saying I'm returning first name and last name here, but we can, because this is acting like variables that are getting declared within the function that we're currently working in. So I could just replace this with first name and last name, but what do you think will happen? Let's actually comment this out, because it's giving away what's going to happen. So if I just return first name and last name and I run this, we get nothing is printed to the screen. And it's because when you have named tuple return, it initializes first name and last name to their 0 values, which is just an empty string for both, and then we go to return it. But if we want to continue along with this example and we want to return first name and last name, how we can modify this function is to still do the whole entire split, but then we can say first name is going to be equal to names at the first index, and then last name will be equal to names at the second index. And so now if we save and we run, we then get Colton G is printed back to us. You'll see this tuple return type for functions very often when you start working with functions that can produce errors. So usually you'll get some value back and then an error, and then you're always saying is error null basically, and if it's null then you can continue on with your program, else you need to handle some type of error. And that's it for the video. You learned all about function basics, so that's naming a function with the access modifiers of using upper or lower camel case, how to write variadic arguments and doing return types and functions. And then lastly, we covered tuple or tuple returns. If you made it this far in the video, I encourage that you subscribe and like, and I'll see you in the next one.